Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code P0966 specifically pertains to the CVT, Continuously Variable Transmission Driven Pulley Pressure Control Valve circuit, indicating a low signal in this circuit. This code refers to an electrical issue within the transmission system of the Honda HR-V, ranging from the 2016 to 2022 model years. It must be noted that this code does not stem from any mechanical defect within the transmission components. Instead, it is strictly an electrical circuit problem affecting the performance of the CVT system. The driven pulley pressure control valve is essential for regulating the hydraulic pressure needed for efficient operation of the CVT system. Diagnosing this error requires a thorough examination of the circuit between the solenoid and the PCM, powertrain control module, to identify any faults. DTC P0966 refers to an issue with the CVT-driven pulley pressure control valve circuit being identified as low. This valve plays a critical role in managing the hydraulic pressure that impacts the driven pulley operation within the continuously variable transmission. This valve is specifically located within the transmission assembly, facilitating smooth transitions between gear ratios based on driving conditions. When this circuit indicates a low signal, it suggests that the solenoid responsible for this task may not be receiving adequate voltage or current. Therefore, understanding the role of this valve helps in recognizing that any fault could severely impact the vehicle's performance and efficiency. Proper diagnosis is crucial to restoring functionality to this important transmission component. The possible causes for the P0966 error code primarily revolve around electrical issues within the CVT system. Firstly, electrical circuit problems may inhibit the solenoid from operating correctly, leading to insufficient voltage reaching the driven pulley pressure control valve. Another cause could be a faulty solenoid valve, which might fail to function correctly, resulting in a low pressure signal. Additionally, wiring issues, such as damaged or corroded wires, can create resistance or an open circuit, disrupting communication between the solenoid and the PCM. Each of these potential causes needs to be investigated using proper diagnostics to ensure an effective resolution of the problem. When DTC P0966 is triggered, several symptoms may manifest, indicating transmission performance degradation. One common sign is poor transmission performance, where shifts may become erratic or sluggish. Additionally, drivers may notice an increase in engine RPMs without a corresponding increase in vehicle speed, which suggests that the transmission is not appropriately utilizing power. In more severe cases, the vehicle may experience stalling, particularly during slow maneuvers or idling. Observing these symptoms can assist technicians in recognizing the urgency of diagnosing and addressing the underlying issue of this trouble code. This attentiveness ensures that the vehicle maintains optimal operational integrity. The first step in troubleshooting DTC P0966 involves a systematic verification process. Begin by turning the vehicle to the on mode, which powers up the vehicle's systems, including the PCM. Next, using the HDS, Honda Diagnostic System, clear any existing diagnostic trouble codes. Clearing the codes is crucial, as it provides a fresh start for monitoring new occurrences. Subsequently, start the engine and wait for at least 1 second to allow the system to stabilize. Finally, check again for any pending or confirmed DTCs with the HDS. If P0966 appears as confirmed, the failure is present, and you will proceed to the next step. However, if no DTC is indicated, this may suggest an intermittent failure or a temporary glitch, requiring further inspection for poor connections and loose terminals. In the second step of troubleshooting DTC P0966, the focus shifts to testing the CVT-driven pulley pressure control solenoid valve. This step is critical in determining whether the solenoid valve itself is functioning correctly. Conducting a proper test will help identify if the solenoid is either in working order or if it has failed, thus directing the troubleshooting process accordingly. If the solenoid valve tests successfully, then the fault likely resides elsewhere in the circuit, leading to the next troubleshooting phase. Conversely, if the solenoid does not function correctly, it implies a direct issue with the valve that will require replacement. Hence, the results of this solenoid test are pivotal in determining the next corrective actions. Step 3 in the troubleshooting process focuses on checking for any open circuits within the wire harnesses. Begin by turning the vehicle to the off mode to ensure safety while conducting this test. Next, utilize the HDS to jump the SCS, Service Check Signal line, initiating a diagnostic readiness condition. After this, carefully disconnect both the PCM connector B51P and the solenoid wire harness 8P connector to prepare for continuity testing. With the vehicle being in the off mode and the necessary connectors disconnected, check for continuity between the assigned test points on the solenoid wire harness and the PCM connector. If continuity is confirmed, the DNLS, driven pulley control solenoid, wire is functioning correctly. In this scenario, updating the PCM software or substituting a known good PCM is the next logical step. Conversely, if there is no continuity, repairs are necessary to address any open circuits within the wiring leading to the PCM. The final troubleshooting step for DTC P0966 requires a thorough examination of the CVT-driven pulley pressure-controlled solenoid valve itself. Begin by removing the valve body assembly from the transmission to gain access to the solenoid. Following this, disconnect the 2P connector associated with the solenoid valve to facilitate resistance measurement. The resistance must be tested under the condition that the vehicle is in the off mode and both the valve body and solenoid connectors are detached. Measure the resistance between the specified points on the solenoid connector. A reading of 4.6 to 6.3 ohms indicates that the solenoid valve is functioning properly. If the resistance falls outside this range, the solenoid is deemed faulty and should be replaced. However, if the solenoid is functional, replace the solenoid wire harness to resolve the issue efficiently. After completing the necessary repairs related to DTC P0966, it is imperative to conduct a final verification step to ensure that everything has been resolved effectively. Start by confirming that the DTC has been successfully cleared from the vehicle's memory using the Auto Diagnostics system. Following this, take the vehicle on a test drive to monitor its overall performance. During this drive, pay close attention to the transmission behavior to ensure smooth changes in driving modes without slipping or hesitation. Observing that the previously noted symptoms do not reappear indicates that the problem has been rectified. If the vehicle operates seamlessly and does not exhibit any DTCs, the troubleshooting process can be considered complete, giving you assurance that your repairs were successful. To prevent the recurrence of issues related to DTC P0966, implementing a routine preventive maintenance strategy is vital for the vehicle's transmission system. Regular system diagnostics should be performed to identify possible trouble codes before they become problematic. Conducting visual inspections of the wiring and connectors associated with the CVT system will help identify any signs of wear or damage, which could lead to faults. Moreover, ensuring timely software updates for the PCM is essential, as upgraded software can enhance the system's performance and resolve any glitches. By maintaining a proactive approach to these maintenance tasks, vehicle owners can help prolong the life of their transmission systems and enhance overall reliability. In conclusion, understanding the significance of DTC P0966 is crucial for addressing potential transmission issues in the Honda HR-V models from 2016 to 2022. Following the outlined troubleshooting steps methodically ensures that you can accurately diagnose and correct any faults related to the CVT-driven pulley pressure control valve circuit. Implementing preventive maintenance measures further assists in averting future occurrences of similar DTCs. By remaining diligent in both diagnostics and maintenance, vehicle owners can ensure optimal performance and reliability from their Honda HR-V's transmission system. Ultimately, awareness of this DTC and proactive resolution strategies lead to a smoother driving experience, contributing to overall vehicle safety and performance. Please like and subscribe to the channel. See you next time!